All right, how's everybody doing? Good? All right. Well, distributed monitoring with Nagios, past, present, and future by Mike Guthrie. Mike's the tech team lead at Nagios Enterprises. He's a developer of Nagios vShell, Nagios BPI, and several other Nagios XI components. So without further ado, here's Mike Guthrie.
Check. All right, so distributed monitoring with Nagios. My challenge with this topic is going to be to actually cover it adequately in roughly 40 minutes because we could probably spend a week talking about it. So most of my challenge for this presentation will be just to cover it on a conceptual level. My goal is that for any of you guys who have a distributed monitoring solution already implemented or you're looking into it for future expansion, I want to kind of present to you guys some different models, different options that are out there and available, so you kind of get a feel for what might work best for your environment. So, all right, so without further ado, basic definition for distributed monitoring is splitting up your monitoring server over multiple machines. This can look a lot of different ways, so I keep it very general in that respect. Why do people use it? There's two main reasons that we hear about the most, one of which is people have multiple geographic locations or they have firewall restrictions where they have to do all their monitoring inside the firewall. They don't want to mess with opening up their ports and opening up their system to the outside world. They keep everything localized inside of their network. And we've had customers say to us, you know, I've only got, say, 100 servers at each site, but I don't want to mess with trying to, you know, break outside the firewall, do all kinds of monitoring, things like that. So they had 4 sites with, you know, 100 servers at each site, but they did 4 separate installations and they tied them all together with Nagios Fusion as a way to do a distributed install. We see that one quite a bit where people, they just don't want to mess with breaking outside the firewall. So that's one main reason for doing distributed monitoring. Another primary reason is a lot of people have some pretty large installations, and this can range from, you know, thousands to, we've got one guy here, Daniel Wittenberg, he's presenting later this week. He, I believe, is overseeing an implementation that monitors 1.4 million services. So if you want to see somebody who actually scaled Nagios to that size and hear about what he actually did to do it, that's a presentation later on this week. So if that's an interest to you. I took a look at his presentation. He tweaked out a lot of stuff to make that work. So it wasn't a simple process getting that set up. So before we dive into the different models, we got to talk a little bit about Nagios Performance, what affects it, why we have to move to distributed monitoring. Main idea is, like, the Nagios core engine, the heart of what's going on with Nagios is that it's primarily scheduling checks. And these checks are, you know, a melting pot of binaries, executable scripts, things like that. And basically what Nagios does is it schedules your checks based on the object definitions and how you define the schedule. So if you have a check interval of 5 minutes, it will run that check every single 5 minutes. Now the challenge as this grows larger is that it is very possible to schedule your checks to happen at basically an impossible rate. We'll give an example here for just an example hypothetical box. So let's say I want to monitor 1,000 hosts and 4 services per host at a 5-minute interval. So that gives me a check load of 5,000 checks that are happening every 5 minutes. You break that down, divided by 5 and then divided by 60 seconds, that comes out to 16 checks per second. Now you think about on a single machine, that's in 1 second, you are launching either 16 scripts or binary processes. The check results going out, results are coming back in, being processed and being written to disk. All that's happening every single second. So as you continue to scale and go bigger and bigger, you're really pushing your processor and your disk I/O quite a bit. As you continue to scale larger, this can be a problem for a single machine. As I said, it's totally possible to create an impossible check schedule for Nagios. You can say, I want to schedule 30,000 checks in under 5 minutes. What's going to happen is that Nagios is going to schedule it, and then it's basically, it can only execute so many checks per second, and your check schedule is going to continue to fall farther and farther behind, and which basically means your monitoring data is getting out of date, farther and farther out of date, and you're going to see what's called check latency for your host and service checks. And that's something that you can look at in your system processes for Nagios. If you see your host check latency or your service check latency continuing to grow larger and larger and larger, it's because you're overtaxing your system. The CPU just can't handle the check schedule it's been given. It can't keep up with it. And it's going to fall farther and farther behind. So as a result, you need to look to either modifying your monitoring configuration. You can maybe space out your checks farther apart, reduce the number of checks, or you can look at a distributed option for spreading out the workload. Bottom line for finding the right distributed model for your environment is there isn't a right or wrong way, and there isn't a best way to implement distributed monitoring. It's purely what works best for your environment. It's going to be different for everybody, so you kind of need to weigh the options that are out there and look at your particular setup and say, what's going to work best for us? As you're doing this, you need to think about the logistics, particularly for the everyday tasks. How am I going to maintain my configuration files? Who's going to handle alerts? Is it going to be on distributed machines? Is it going to be all at a central place? Think about the everyday tasks that are going to happen, because as you continue to scale larger and larger over several servers, like I put on here, a 30-minute task on one server isn't a big deal, but if you have to do it 10 times and you have to do this once a week, that's 5 hours a week. So things kind of add up very, very quickly as you distribute your monitoring environment over multiple machines. So think logistics, think everyday tasks, and create a plan. Every hour of planning that you do is going to save you, tens, 20s, hundreds of hours in actual maintenance time later on. That's costing the company money. So take that into consideration of how you're going to implement it and how you're going to actually maintain it once it's implemented. Something that I've kind of seen too, as your quantity of data increases, getting the useful information out of it becomes a little more challenging, and yet it's something you have to think about as well. For Nagios Core, you can get Nagios Core souped up pretty good. If you've got, say, 30,000 checks running with Nagios Core, that's pretty awesome. But if you look at the services page, you're going to have 30,000 services on one page. So you need to think about how you're going to filter the information, how are you going to effectively view it so you can actually see the information you need to see. Talking with another system admin from Australia, his comment was, I'm not concerned so much with what's working as what's not working. So think about how you're going to keep track of the information and what's important, and how you're going to effectively view it as you continue to scale larger, or even if you just have a multi-site distribution, how am I going to effectively view my monitoring data on 4 different locations? Let's see. Move on, next slide here. So the first model I'm going to cover is kind of I call it the classic distributed model. And this is actually straight out of the Nagios Core documentation. You can find this in the core manual. I kind of redrew the diagram, and of course my image didn't come out straight now, but that's all right. It's basically, the idea is that you've got active checks running on external distributed servers. These servers are all initiating checks and processing the results, and then they're actually forwarding them onto a central server. And the central server doesn't do any active checking on its own. All it does is receive results. And the reason this has worked in the past is that this server isn't launching any new processes. All it is processing data as it comes in. The central server just acts as a central viewer primarily, whereas all of these servers are working, doing the actual checking. And like I said, with every single check that's run, as a result is received, the results are forwarded on to the central server. A little bit more in-depth model, and this is, again, straight out of the core manual. The way this actually works is that you've got the distributed servers, and with every single check, you define what's called an OCSP command, which is Obsessive Compulsive Service Processor command. Very long-winded acronym, but it basically means that every time a check result is received, run this command. And so you can define this. It can be pretty flexible. You can define this command however you want. It can basically be a shell script. It can be a binary. It can be whatever you want it to do every time it receives a result.